it's very possible when you see a question like number 14, it's not going to tell you to find the slant asymptote. It wants you to recognize when a slant or oblique asymptote occurs in a rational function. As a quick reminder, when the degree in the numerator is 1 greater than the degree in the denominator, a slant or oblique asymptote occurs. Now, how do we actually identify the equation of that? We're going to do polynomial long division. 3x plus 9, x squared minus 3x plus 2. Now, notice that I've made sure we have degree 2, so we have some quantity to the second, to the first, and to the 0. Again, here's degree 1 and degree 0. Everything's accounted for. 3x times what is x squared? Now, this is difficult. 3x times what? So what would I have to do? I'm going to write this off to the side. What would I have to do to 3x to have it equal 1x squared? That's what I'm being asked. Well, if I need to turn it into a 1, and currently it's a 3, I would have to divide it by 1/3. 3 times 1/3 is 1, and I need 2 x's, I only have 1. So in this position, I'm going to write 1/3 x. Now, I'll know if I did this right, if I chose the correct quantity. When I multiply 1/3 times 3 is 1, and I have x squared. 1/3 times 9 is 3, and I have 1x. Change the sign of everything in the second row, and then we're going to combine. Additive inverses, -3 is -6. Bring down, and we're going to start it all over again. 3 times what quantity? 3 times what quantity is -6? 3 times what quantity is -6? And that's going to be a -2. I already have 1x here, so I don't need to add an additional x to come up with 1x. I'm going to multiply to get -6x, multiply to get -18, change the sign of everything in the second row, and add straight down. And so this remainder, we're only using the tool of polynomial long division in order to figure out what is that equation of the slant or oblique asymptote. So our equation of the asymptote is going to be what's on top. So 1/3 x minus 2.